Hey there, we're looking at similar objects now. It's not unlike similar figures that we were doing before. And two things or objects are similar if the ratio of their lengths of corresponding sides are equal. Now, what does that mean? Okay, well, let's look at these ones. These two, you know, I keep staring at that and they don't look square. It's supposed to be square paper. All right, so from there to there is 22 millimeters. And from there, oh, it is off by a little bit. They're not exactly square. Well, then this works just fine. All right, so we're going to prove these are similar. I got to measure really, really carefully. I can see better going this way. Give me a while to move stuff around to make it work. All right, so that is 9 millimeters. We'll measure this one while I'm at it. That is 22 millimeters. If we measure it this way, I was going to say, you should see, I'm sure you can tell that I've got this. Okay. Oh my goodness. It's like 9.5 millimeters. It's so close. And this side is 21, 22, 23 and a half. All right, so here's how this similar goes. That, for the record, those were supposed to turn out to be exactly alike. That's okay. I mean, this side and this side. So what I do is I go, I'm going to compare the distance over the top, 9 millimeters divided by 22 millimeters. Nine divided by 22. All right, so 0.4090. I'm carrying a whole bunch because I know it's going to be really close with rounding and everything on this one. Hold on. All right. Okay, let's put my bit down. Oh, camera. There we go. All right. So when we compare the top sides, top to top, we get a ratio. And now I'm going to do the two heights or whatever this is. 9.5 millimeters over 23.5 millimeters. So 9.5 divided by 23.5, 0.4042. Okay, so if we went to, they're almost the same. Let's just call it measuring error because these are pretty small. If we go to one decimal place, 0.4, 0.4, that's the point. Is when you do that comparison, those corresponding sides are in proportion. Okay, so let's take a look at our triangle here. And I'm hoping the computer worked with me. Let's measure this side. And that looks like 34 millimeters. And now we're going to measure this one. And I get 21 millimeters. Sorry. I know my phone just went off. And this is 28 millimeters. And this one is, measuring really carefully, 15 millimeters. All right, now we're going to compare to side. So I'm going to do 34 compared to 21. And then we're going to do bottom to bottom, 28 over 15. Make sure you get them right. So you want to compare corresponding sides and also in order, right? So it was the big one and then the small one, big one, small one on that side. So 34 divided by 21, 1.62. I'm not going to carry so many decimals because I don't think my measuring is accurate enough. Then we go 28 divided by 15, 1.87. All right. Well, I'm going to stop doing this. And I'm going to fess up. The reason these aren't working is because these diagrams are really small and my ruler is not particularly accurate. If these pictures were bigger, we get a better comparison. And I was just using my computer to do similar ones, so it might not be the most accurate on doing it. So yeah, the numbers should be the same. I'm gonna leave it out. I think you get the idea. I don't think I have to redo the video with bigger numbers. What I did want to show is if you start to compare these two, make sure you're going to compare this side with that side, right? So basically you need to take this little guy and join them. You always want to do corresponding. See, that's what this part means. Corresponding sides, it's not compare the top with the top, because that's not going to work at all. But you need to move this guy, put him horizontal, and then you can compare. What I wanted to show you here is, whoops. These two are not similar. I tried really hard to get the same height. So this one compared to that one would be 1-to-1, but this is way longer than that one. So if you did the math here, we'll see how close I am. Okay, so that's 22 millimeters. And this one is 22 millimeters. And this one is 41 millimeters. And this one is 26. So when we compare these guys, if we do the vertical part, it'd be 22 over 22, which is equal to 1. And then if we do 41 over 26, yeah, I don't know, but it's not close to 1. 41 divided by 26, 1.57. So you can see those ones are not even close to being similar. All right, after all that work and an explanation of what similar means, we can do this quick little tractor question. All right, Esmeralda bought this toy tractor to give her younger brother for his birthday. The scale ratio on the package is 1:16. Determine the dimensions of the real tractor. All right. So K is 1/16. So 1/16. And we're going to do it like we did before. Let's do 1, do the math properly, and then look for the pattern. And then we can do the other ones quickly using that pattern. Now, it's always the scale model over the real. So this is going to be 19.1 over That's what we're looking for. We want to know how big the tractor is. So basically the tractor is 16 times bigger than this. Cross multiply. 1x 16 times 19.1. 16 times 19.1 gives me 305.6 centimeters. All right, so what do? Yeah, we just multiply by 16. So for the other ones, you can just go 9.5 times 16 and 12.7 times 16. So 9.5, 152, or 12.7 times 16 is 203.2 centimeters. Remember your units, and there we go. We have the dimensions of the real tractor. So either you have to prove two objects are similar by comparing their corresponding sides, which is what we were trying to do up here. I think if I gave you a question like that, I'd probably just give you the measurements, and then I could make sure the question worked. Because obviously measuring it's off by just a little bit. Okay. Or if you know the objects are similar, you can determine the lengths of the corresponding sides. So we figured out, we knew how big the little tractor, the scale tractor, the toy tractor, I'll get it there, the toy tractor was, and then we can figure out how big it was in reality. So scale diagrams, pretty cool.